Hello, welcome back, and a special welcome to our new viewers. In today's lesson, I'll be talking to you about compound percentages using the multiplier method. Compound percentage involves increasing or decreasing an amount or value by the same or different percentages for multiple years. It could be growth when there's a percentage increase. It could be decay when it's percentage decrease. And the formula that I will recommend to you is giving us always the original amount or the original value. You times it by the multiplier that you create from the question raised to the number of years that is said in the question. So let's look at examples and see how we make use of this formula. Let's look at example 1. Andrew left 16,500 in the bank for 6 years. It earns compound interest of 3.5% each year. Calculate the total amount Andrew has at the bank at the end of 6 years. So how do we know it's a compound question? Well, most of the time the compound is mentioned in the question. If not, we are earning this 3.5% over a number of years, so that is continuously compounding. First is because we're going to earn interest 3.5%, our money is going to go up, so it's an increase. So let's create a multiplier of 3.5% increase. Original amount is always 100%, so 100 plus 3.5, 103.5%, always divided by 100 to get the multiplier. So that is our multiplier. Now, how many years is given the question? 6 years. How much money did he invest? £16,500. So put into the formula, total amount is equal to the amount that you invested times it by the multiplier to the power 6, and you're allowed to use a calculator. So that tells you at the end of 6 years, Andrew is going to have £20,282.71. So that's the amount that Andrew is going to have. Sometimes the question might ask you, work out the interest that accrues to Andrew at the end of 6 years. It's exactly what you just work out minus what you invested. So the difference here will give you the interest. So if we ask to work out the interest, the same working out, just take the original amount from the new amount. Example 2. The population of a city grows over time. Every year the population grows by 2.8%. How many years will it take the current population of 8.4 million to exceed 10 million? Now you realize that this one, there is no keyword compound, but the percentage is going to be the same over number of years, so it's continuous. Set up the same principle. If you have 2.8% increase, get the multiplier first. 100 plus 2.8, 102.8% divided by 100, so that's our multiplier. The question is saying that how long is it going to take? So we begin with 8.45. We have a multiplier. We don't know the number of years, so we call it n or t or x. So we put in the formula. This is what we have: 8.45 times the multiplier to the power n. And the question is it going to be taking 1 year, 2 years, 5 years, 7 years? You don't know. So in GCSE, calculator is allowed. All you need to do is keep changing n to 1, 2, 3, 4 until the number that will make the population just exceed 10 million. And if you try, you realize that the answer will be 7 years, because 7 years gives you 10.25 million. 6 years give you 9.97 million. So therefore the answer is 7. Going to take 7 years. So based on the same concept of using multiplier and compounding, just know the formula that you are using. Next slide, we're going to talk about compound decay, where there's a percentage decrease. That will be the same principle, but it's going to be a decay.